Alright kids, now we're going to go through part B of the test, or at least some parts of it. So here we had some data, and you need to figure out the slope between 5 and 7 milliliters of water based off of either this chart or this table and this line graph. So I gave you the slope on the board, which is m equals y2 minus y1. Divided by, I guess I should just write it like that, divided by x2 minus x1. Wish I could display it better as a fraction, however, that's what we got. Alright, so what does this look like? So y2 minus y1 is that 5 and 7. You see on our x-axis, we have volume in milliliters, and they're giving us milliliters here. So these are going to be x values. So our x2 minus x1 are going to be 7 and 5. Why am I calling 7 x2? Because it comes later on the x-axis. So here's 7, going to be in between 6 and 8, and here's 5, going to be in between 4 and 6. So this will be my x1, and this will be my x2. So I'm going to have m equals y2 minus y1. I'm going to rewrite this and plug them in as we go. And x2 minus x1. And I said that the later occurring x on the x-axis is x2. That's 7. So let's plug that in there. And 5 coming after 4. It's right here on x1. And what corresponding y values match those x values? So let's start with 7 because it's first here. Y2. 7. Go up to the line. And that, if you're going over the trend line, or I should say, if you're using the trend line versus the actual data, you're going to get to around 150. But if you look at our table here, it gives you the y value exactly for 7. So that's 155. And what's our y1? The corresponding y to x1. Here's the 5. Go up, go across. It's 84. So notice that if you were here on the x-axis with 5, you can either go to that trend line or you can go to the real data. The real data in the table says 84. Okay. So now we have our numbers plugged in. We need to solve that. 155 minus 84. 5 minus 4 is 1. And 15 minus 8 is 7. So that's going to give us 71 divided by 7 minus 5, which is 2, which is going to give us 35.5. Now the question is, what are the units of that? Remember, we have rise over run. So again, this is rise divided by run. Our rising was drops of water, and our run was volume. So that's going to be a rise in drops per run, which was milliliters, the volume. So that's how you do that problem. Let's walk through this one now. I'm going to go ahead and do a little copy pasting. So they're giving us again the x values, 7 and 9 milliliters. So let's plug those in down below. X2 is 9 because it comes later on the x-axis. X1 is 7. And what are the corresponding y values based off the table? The 9 is 192. See these two corresponding points. And the y1 is 155, matching the 7. So it's 155. And what does that equate to? Go ahead and paste again so I don't have to copy all that. 12 minus 5 is 7, and 18 minus 15 is 3, so that'll be 37, I believe. 37. And again, we have a 9 minus 7, a difference of 2 on our x change. So 37 divided by 2, that's going to give us 18.5. And since we're talking about the same slope of the same data, the units again are going to be drops per milliliter. All right, moving down, or moving on, I should say, or both. Record the following measurements to the appropriate number of significant digits that the tool allows. I showed you this earlier in the last video, but again, here's 20, here's 30. We have 9 graduations, or is it 8 graduations in between? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now here's the deal. Because you know that this is 20 and this is 21, and anything in between is going to be a decimal after 20, that means that this is actually 20.0 exactly. And this is 21.0, 22.0, 23.0, 24.0, 25.0, 26.0, and so on until this is 30.0. So 25.0, 26.0, the bottom of this curve is below the halfway point, so I know that this is below 25.5. And I know it's above the line 25.0, so I know it's not that. It's between 25.1 and 25.5. So actually the right answer to this is anything in between 25.1 milliliters and 25.4 milliliters. I should say in between or exactly 25.1 and 25.4. Remember, we call this last digit an uncertain digit. So within there is a range of certainty, and that's the range. So if you put anything in between equal to these or in between them, that's a correct answer. Okay, same deal. Record the following measurements to the appropriate number of significant digits that the tool allows. Again, this should say 10.0, this should say 20.0, and every line in between is going to be 0.0. 11.0, 12.0, 13.0, 14.0. It's obviously above halfway in between 14 and 15. So I'm going to go ahead and copy this right here and give you the range that I would accept for that. Anything in between are exactly 14.6 and 14.9. Now, obviously, you could make a good argument as to why that's equal to 14.8 or less. But again, there's uncertainty in that, and that's what we would allow. Moving on. Below are the results from a lab experiment using the data table to determine which two samples make up the unknown. What is one of the samples in the unknown? So the unknown fizzes with water, reacts, which usually when these powders react with vinegar, to form bubbles, and turns orange with iodine. So what's one of those samples? It's going to be one of those that does those things. So an example that could work there would be sample C, which fizzes and turns orange, or fizzes, reacts, and turns orange. So C or D. C or D would work as one of them because they like the unknown. Fizz with water, react to bubble with vinegar, and each also turn orange with iodine. So you could also make the argument that, again, the exact same thing. C or D would work as one of them because they like the unknown, fizz with water, react to bubble with vinegar. Oh, sample C does not. So, all right, C does not for react to bubble with vinegar. So if you were to put D here, your C would need to be up here. If you were to put D here, your C would need to be down here. And again, C does not react with vinegar. Explain why you picked those. I kind of put the explanations in there for you. So I would make the argument my unknown contains C because it turns orange with iodine and fizzes with water. My unknown also contains D because it does the same thing as C, but also brought bubbling from vinegar to the table. And I guess let's not use any metaphors to the unknown. Alright, now we have a water displacement problem, which means if you drop a rock in here, it's going to raise the water volume that much. The student performed a volume by water displacement attempt on this object, but couldn't read the graduated cylinder. This is actually the same graduated cylinder. So this is a depiction of graduated cylinder before the rock went in it, graduated cylinder after the rock went in it. But couldn't read the graduated cylinder. If you're remembering this process correctly, you should kind of understand that concept. If you drop an object in here, it's the before and after of the volume change that's going to allow you to tell the volume of the object. You determine the volume for them based off of the picture, which this is 2.0. These increments, there are 1, 2, 3, 4, 5 increments, which means this is 0.2 each. So 2.2, 2.4, 2.6, 2.8, 3.0. There is an estimated digit after that, but for the purposes of this problem, I did not count that against any student. So V final minus V initial equals volume of the rock. And I guess I should say volume of water final minus volume in the cylinder initial. Volume in cylinder initial is 1.20, looks like. I'll copy this right here. No need to copy. Final is 3.0 milliliters minus 1.2 milliliters equals 1.8 milliliters. Should probably be 1.80, but let's, if you put 1.8, I gave it to you. All right. The teacher performed the same measurement and determined if the object to have an accurate measure of 1.85. If the student's measure was 1.90, then what's the percent error? All right, so there should be an absolute value symbol right here and right here. It actually doesn't matter if you put experimental here minus accurate, and as long as you take the absolute value after the fact. But let's go ahead and do this. So the accurate value was 1.85 minus 1.90, and let's put those in parentheses and divide by the accurate, 1.90, and we should take the absolute value of this, absolute value of all that, and then times 100, then times 100. If you had done that, that should have given you 0.027, and then times 100 equals 2.7. All right, that's how you do all of part B. I hope that helped. Good luck.